Yes. Hi guys. Today I have to talk about the other methods of expansion of functions like this. You expansion by formation of differential equations. And I've taken in the two methods, and today I have to explain the two methods. First is by forming differential equations, and next is by differentiation or simple integration. Okay, and this is explain the following by differentiation or integration of known series. So these are the questions based upon the second method, and first method I have taken the three questions which are very important one. Okay, to explain this forming differential equations. What the process of this? Here are the two next methods. Before that, I have talked about what is Maclaurin theorem, okay, Taylor's theorem, etc. So all those processes were discussed, and now let me talk about how to form a different expansion by formation of differential equations. First of all, in this process, we have to form a differential equation. Okay, by suppose a function is given, then find derivatives, first derivative, second derivative, third derivatives, and so on. Okay, and after forming that equation, okay, or that formation, then we assume one hypothesis. I'll talk about that y equal to a naught plus a1x plus a2x squared plus a3x cubed, etc. Okay, plus and so on. Now the coefficients of this equation can be found out, okay, easily found out just by differentiating this, but except one or two. Okay, first and like y naught 0 we cannot find out from this equation by equating coefficients, and y1 naught 0, y2 0, etc. They can easily be obtained from the given differential equations. Okay, in this way we can find the coefficient, and after that we will form a differential equation by expansion of this. So expansion by differential equations, let me explain. First of all, first form a differential equation. First form a differential equation. First form a differential equation. Differential equation by simple derivatives. By simple derivatives found from the given equation. From the given equation or function. From the given function, whatever given function is, you have to find out derivatives, first derivative, second derivative, third derivative, etc. Okay, and then let assume an hypothesis. Then let's assume a hypothesis. Hypothesis y is equal to a naught plus a1x plus a2x squared plus a3x cubed plus and so on. Okay, this is the first equation. Now the coefficient is a naught, a1, a2, a3 we have to find out by simple differentiation of this equation. Okay, then to find the coefficients of first first means this equation, or this equation, this first one, like a naught, a1, all these coefficients, a2, a3, etc. Okay, we equate the derivatives at x equal to 0, and then substitute the values. Then we substitute the values of the coefficients and thus obtain the equation. And thus we will obtain the given differential equation. Okay, given equation. So this is the process. Now let me take all these questions which are taken there. Okay, these questions will explain that how to form a differential equation, or how to expand a function or series given with the help of differential equations. Okay, forming a differential equation. Now let me take the first. Expand sine inverse x square. Okay, sine inverse x whole square in ascending powers of x. Okay, and then expand the following using formation of differential equation. The questions I am taking. Let me take the first question here. Here it is. Let y equal to sine inverse x whole square. Okay, so let me differentiate this. Differentiating it with respect to x, we get this is y1 equal to twice sine inverse x into 1 upon under root 1 minus x square. Why? Because first to sine inverse x, but sine inverse x is not x. We have to differentiate it again. So differentiation of sine inverse x is 1 upon under root 1 minus x square. Okay. So if we cross multiply this either, let me cross multiply this. This is 1 minus x square into y1 equal to 2 sine inverse x. Okay, now if I square this, squaring, we get, or on squaring we get, this is 1 minus x square into y1 square equal to 4 into sine inverse x whole square. And now this sine inverse x whole square is nothing but 4 into y. Okay, so this is 4y, or this is y. Y is sine inverse x whole square. Now differentiating it further. With respect to x, we get differentiation of this by product rule. This is 1 minus x square into y1 square. This is y1 square. Okay, y1 whole square and equal to 4y. So let me differentiate this. This first function as it is, 1 minus x square as it is. Differentiation of y1 square, that means twice y1, but y1 is not y, not x. So this will be second derivative y1. Is to differentiate it further, so differentiation will be by 2, that means second derivative, or d by d square by upon dx square. Alright, this is by 2 plus. Now differentiation of 1 minus x square and y1 square as it is. Now differentiation of by 1 minus x square is minus twice x into y1 square is equal to 4y, that means 4 into y1, because derivative of y is y1, dy dx is y1. Okay, now dividing this whole equation by twice y1, I'm dividing this equation by twice y1, we get, if I divide by twice by 1, you will get 1 minus x square as it is, twice by 1, that means by 2 only. This is minus 2 by 1 cancel out, so this will be x by 1 equal to 2 only. This twice by 1 divided by 1 cancel out, 2 is 4. So this is the third equation. Let me take, this is the third equation. This is the second equation. Which one? In y1, this was in y1. Let me take this as second equation. This is the first equation. Now if I find out y1, y2, y3, let me find out y0. From this first one, y0, this is at x equal to 0. y0 is at x equal to 0. So this is sine inverse x, 0 is 0. For 0, it is 0. Now here y1, 0 is also 0, because 2 into sine inverse 0 is 0. This is y1 0. Now y2 0, this y2 0. In the last third equation, we get this 1 into y2 0, because this x is 0, and y2 0 therefore will be, this is 0 equal to 2. This is twice. Okay, so now this is the equation given to us. Now if I find out the next process is that by learning theorem we have to find out another derivative of this, then form a equation. Okay, that can also be done. And if I assume that what is y equal to a0 plus a1x plus a2 is x square, then form the differential equation like this. Okay, this one is also of the second equation. This is second question. I'm sorry, I'm not doing this one, but from first one we can obtain this. If nth derivative is to be calculated of this by Leibniz theorem that we take. Now by using Leibniz theorem, nth derivative, nth derivative of this equation, that means dn of this 1 minus x square into by 2 will be equal to how much? 1 minus x square as it is. Then the derivative by 2 is by n plus 2. Okay, then this nc1, that means n only, minus sign because minus twice x is derivative of this. Let me take plus minus twice x into by n plus 1 lesser than this n derivative. Next will be derivative of twice x is minus 2, that means minus 2 into nc1 n minus 1 upon 2 factorial into by n, nth derivative of this one. So 1 lesser than by n plus 1, that means by n. This we know about. Now nth derivative of this minus x by, so dn of minus x by 1 is equal to, this will be below this. So this is 1, nth derivative will be by n plus 1. So this is below by n plus 1. This will be minus x is here by n plus 1. Next derivative of x is minus 1. Minus x is minus 1. So next step will come here. This is n into by n plus by n only. This is n into by n. The reason is derivative of x is minus x is minus 1, minus sign, but nc1 is n, and nth derivative of by n plus 1, next lesser than this, so 1 less than this will be by n. Okay, now adding these, because the derivative of 2 is 0. Now this whole equation is differentiated nth time. Now let me find out then what is its derivative, nth derivative. Adding on addition we get, okay, second derivative was, okay, let me find out this first, and then it will be 1 minus x square into by n plus 2, this one, minus these two, this will be minus twice n plus 1 into x into by n plus 1. Why? Because this is minus twice x and twice n x, this is minus x common, so this is minus twice n plus 1 into by n plus 1. Now last this one by n term. By n term is 2 to cancel out. This will be n square minus n with minus sign. It will be minus n square. Okay, and inside it will be minus n plus n, because if I add these two, this is minus sign are taken in the second one common. Here they are double negative, so it will be negative. This is negative. Okay, so into by n, this n cancel out, equal to 0. So this in the left hand side it is 0. Sum of these two is 0. And the derivative of this function plus minus and the derivative of this equal to 0. This is 0 in the left hand side. This is the equation. We get nth derivative of this equation, minus twice n plus 1 into x into by n plus 1 minus n square into by n equal to 0. Now this is nth derivative, but suppose we have to find out the coefficient, values of coefficients is substituting. For example, by 30 we have to find out, by 40 we have to find out. That is not calculable. Okay, calculator till we have to use this equation to form a differential equation for this one, second one. That was 1 minus x square. Okay, this was the equation 1 minus x square into by 2 minus x by 1 equal to 2. This was the, I think, second or third equation. This was the third equation, and this is the fourth one after. Now this third equation, from this third one, we are able to find out y20. Now y30 we cannot calculate. So for the next coefficients of derivatives at x equal to 0, y30, y40, yn0, etc. For that we have to assume. Let's take the hypothesis. Let's assume the hypothesis y equal to a0 plus a1x plus a2x square plus a3x square, x cube, a3x cube plus and so on, plus n minus, this is a n minus 2 into x raised power n minus 2. This is n minus 2 plus a n minus 1 x raised power n minus 1 plus a n x raised power n plus and so on. Okay, so this is a n into x raised power n. This is the hypothesis we assume. Now from this we have to find out what the value of coefficient a0, a1, a2. Then the equation can be, the differential equation can be calculated. So to find out the coefficients a3, a4, etc. from this equation we have to equate the differential coefficient. Now if I differentiate this equation, it will be by 1, this is a1 only, plus twice a2x plus 3a3 x square plus and so on, plus let me take this one, this is n minus 2 into a n minus 2 into x raised power n minus 3, okay, plus n minus 1 into a n minus 1 into x raised power n minus 2 plus n into a n x raised power n minus 1 plus n plus 1 into a n plus 1 x raised power n, okay, plus next one is n plus 2, okay, into a n plus 2 x raised power n plus 1. Okay, so this is, if I find out by 2 derivative of this, it will be twice a2, so 3 into 2 into a3 x only, plus and so on. From this one, this is n minus 2 into n minus 1 into a n minus 2 x raised power n minus 4 plus, we write next one is n minus 1 n minus 2 into a n minus 1 x raised power n minus 3, okay, plus in this one, this is n into n minus 1 into x raised power n minus 2 plus n plus 2 into n plus 1 a n plus 2 x raised power n. Okay, only up to 2. Now if I substitute these values in this equation, the third equation, in place of y2 and y1, and equating this equal to this, or it can be written as 1 minus x square y2 equal to x by 1 plus 2. In place of y1 and y2, if I substitute these values, y1 and y2, okay, in this equation, what we get, substituting these values of y1 and y2, values of y1, y2 in terms we get, so here we get what? Now this is 1 minus x square into y2. Now y2 is this value. Let me write only, because you have to multiply by 1 to the nth, then you will equate the coefficient of x raised power n. X raised power n is this last term, okay, this one, and if I multiply by x square, the term n minus 2, that means this equation, that will be x raised power n only. So let me write only these two terms. This is, let me write here three dots. After that, n minus 1 into a n minus 1 x raised power n minus 2, okay, and then plus, and so this is by 1 I've taken, this is not by 1 but by 2, I'm sorry, by 2 is this one, n minus 2 is this is n into n minus 1 into x raised power n minus 2, okay, and then this last one plus n plus 1, sorry, n plus 2, I'm not, this n minus 2 I've taken, where is n minus 1, it must be n plus 1, then okay, only this I've taken, sorry, okay, so n into n minus 1 into x raised power n minus 2 plus one step I have left, plus n in plus 2 into n plus 1 into a n plus 2 x raised power n. Okay, so this is in place of by 2. Only these two steps are taken. I'll tell you that why I have taken only these two steps. Because if I multiply by 1, then this x raised power n, this term we have to select. Why? Because we have to equate the coefficients of x raised power n from this side and 2 equal to this one, x by 1. Now next step, x by 1 equal to x into y1, this x into y1. By 1 step I have to substitute, because I have to multiply by x. After multiplication by x to this n a n x raised power n minus 1, it will become x raised power n. This equation, this step I have to write only. This is plus n into a n x raised power n minus 1. Only other steps are left, because only this step will be x raised power n over n. This is n minus 1 here. So if I multiply by x to n a n minus a n x raised power n minus 1, it will become n a n x raised power n, this one. Then equate the coefficient of x raised power n from both sides, left hand side and right hand side. Okay, after putting these values of y1 and y2 in this third equation, y2 and y1 values of, and after that we have to equate the coefficients of x raised power n. Now let me equate the coefficients of x raised power n. Equating the coefficients of equating the coefficients of x raised power n, okay, from left and right side, from LHS and RHS, we get, now from left hand side, if I multiply by 1, so this is step, this one, that means n plus 1, sorry, n plus 2 into n plus 1 into a n plus 2. This is x raised power n. I have only taken the coefficient of this. This is one coefficient. Then if I multiply with minus x square to this step, it will become negative x square into x raised power n minus 2 will become x raised power n. This is the coefficient, sorry, this, into this an, yeah, an step is there. This side an is there, so this is minus sign. Okay, n into n minus 1 into an, this coefficient of an, this is n into n minus 1 an, x is for n minus 2. So if I multiply this x square minus x square, then it will become coefficient of xn. Why? Because power of x is n minus 2, this is plus 2, so n minus 2 plus 2, plus 2 and minus 2 cancel out. It becomes x raised power n. So coefficient of x raised power n will be n into n minus 1 an, this one, equal to, from right hand side, x into this term will become n into an. That means x raised power n will become. So equal to the coefficient of x raised power n. Now take this an to that side. We will get n plus 2 into n plus 1 into an plus 2 is equal to nan plus n square minus n will become plus n square minus n into an. If I take an common, coefficient of this will become n square only, because n and minus n cancel out. Only n square, or this is equal to n square into an. Hence we get value of an plus 2 in this case will become, therefore an plus 2, the coefficient of an plus 2 will become n square upon n plus 2 into n plus 1 into an is an. Okay, now to obtain the coefficients of what you call an, a3, a2, this by 2, 0 we have obtained. So from the equation given, is by equal to, it was a0 plus a1x plus a2 x square plus a3 x cube plus and so on. Then we obtain by 1, by 2, by 3. Okay, if I find out by 3 0 from this equation, it will become by 3 0 equal to, here by 3 0 if I find out, it will become factorial 3, because 3 into 2 into 1 x cancel out, so it will be factorial 3 into a3. So a3 in this case is a3 equal to by 3 0 oblique factorial 3. Now by 3 0, okay, a3 0 value is this. Now by 3 0 if I find out, or if I substitute the values by 3 0, which is equal to this one, and a3 is required, that factorial 3 into a3, okay, that we will substitute in place of by 3 0 in this case. So a1 can be calculated. So by 3 0, if I calculate from this equation, it will become factorial 3 into a3, and a3 can be calculated from this equation. So for higher coefficients, we have to use this equation. Okay, so for higher coefficients, we have to use this equation. For example, if I substitute n equal to 1, it will become a3. Okay, so a3 is equal to 1 square upon 3, 1 plus 2, 3 into 2. That means 1 upon factorial 3 into a3 into a1. Back into a1 equals 1. This is a1, but a1 is what? Or 1 upon 3 into 2. This is factorial 3, 3 into 2 into 1 into a1. Now a1 can be calculated from this. By 1 is 0, so it is 0. Why? Because if by 1 is 0, that means a1 is also 0. By 1 is 0, at x equal to 0, a1 will become 0. A1 is 0 from the same equation. From this equation, if I find out by 1 0, that means a1 into x 0, or x is already 0. So only, sorry, x is not there in with this 1, and other terms will have x, so that they will become 0. a1 0, or a1 is equal to y1 0. Okay, so y1 0 is 0, y1 0 from this one is 0, so a1 0 is 0. So that means a1 bar 0, so this is 0. Then a4 can be calculated by substituting 2. a2 0 is 2. This y2 0 is 2. That means factorial 2 or 2. So a4 is equal to here. So a3, in this case a3, a5, odd number terms coefficient will be 0. Now a4 will become this equation 2 square upon 2 plus 2 4 into 3 into a2. But a2 is from this. If I find out this, so y2 0, let me write here y2 0 is 2. And what is a2 0? So y2 0, if I substitute, that will become factorial 2 into a2. a2 0 is 2, value of a2 0. So y2 0 or y2 upon this, right? So a2 0 is y2 0 upon factorial 2, but y2 0 is 2, so 2 upon factorial 2, that means 1. This is 1. 2 square upon 3 into 4 into 1. Why? Because this factorial, sorry, y2 0 upon factorial 2 is the value of a2. If I substitute value of y2 0, which is 2, 2 upon factorial 2 means 2 equal to a2, a2 equal to 1. 1 I'll substitute here. This is equal to 2 square upon 3 or into 4, that means 1 upon 4, 1.3 only. 4 and 4 cancel out. 1.3 will become value of this a4. Similarly, a6, a8, etc. even terms can be calculated. In this way, coefficients are calculated. Okay, for the first equation. In this way, we form the differential equation by finding out coefficients as well as the values of derivatives at x equal to 0. Okay, so this is the process of finding out derivatives. Now let me take the next question, second one. Here we have to prove that if y is equal to sin inverse x upon under root minus x square, where this is there, y1 is less than x less than 1, and minus pi by 2 less than sin inverse x is less than pi by 2, or sin inverse x lying between minus pi by 2 and plus pi by 2. Then prove that this value 1 minus x square into yn plus 1 is equal to minus twice n plus 1. This we have just proved in the similar fashion, so we will prove this. Then this is by n plus 1.